Let's look at Android startup init process. When we talk about init process, we must first look at the steps of Android system startup process. So here is a timeline diagram of Android boot process. So in this diagram, the first step is the power on and system startup. When the power is pressed, the boot chip code starts executing from a predefined place. And this is basically hard-coded in the ROM. This loads the bootloader into the RAM and executes it. So whenever we press the power button in a mobile device, it starts executing from a predefined address which is hard-coded in the ROM. Okay, and this will load the bootloader into the RAM and executes it. So bootloader is a small program which runs before the operating system starts running. Its main function is to start the system OS. So in our case, this bootloader will start the Linux kernel. So as we know, Android is based on Linux kernel. So the bootloader is basically responsible for starting the Linux kernel. So once the Linux kernel starts, it sets the protected memory, cache, and it loads all the system drivers like the audio, video, graphics drivers, all sorts of drivers. When the kernel finishes setting up the system, it looks for the init.rc file. So there is a file, a configuration file, init file. Okay, so it will first look for init files in the system files, and then it starts the root process or the first process in the system, which is called the init process. So in this session, we are going to dig deeper into the init process. Okay, we'll see what all actions are being performed in this process, and we'll have a code walkthrough and see which files or which modules are responsible for this init process. In the later tutorials, we will cover Zygote, system server, system UI, and launcher. The init process mainly does four things. So the first step is to create the folders and mount the device. So in the first step, it basically creates the file system of Android. In the second step, it creates the SC-Linux policies. So in case if you don't know what SC-Linux is, SC-Linux stands for Security Enhanced Linux. SC-Linux is a set of rules to improve the security of your system. So I have created a different tutorial for SC-Linux. So you will learn about that later. So in the third step, it will initialize and start the property service. So Android maintains a set of properties. It is very similar to the registry entry in Windows. So you might have seen the regedit in Windows, right? Where we have a property and value pair. Android also does something very similar. So in Android, there is a set of properties which has a key value pair, property name and the value. And this property and value are used in a lot of places in Android. By using ADB, we can get the list of these properties and their values. I'll show you how to do that. Then in the fourth step, we'll parse the init.rc configuration file and start the Zygote process. So we'll cover the Zygote process in a separate tutorial. So in this tutorial, we will see how the Zygote process is getting started. Let's look at the modules which implements the init process in Android. So you can find most of the init modules within this folder. So it is within AOSP, system, core, init. I have bookmarked the most important modules. So here we have the main.cpp, which consists of a main method. Okay, within this method, we could find three methods which are pretty important. So the first one is first stage main. The first stage main method is mainly responsible for creating the directories and mounting the devices. So we can see that it's mainly mounting the devices and creating the directories here. Second, we have the setup SC-Linux method. So within setup SC-Linux method, basically loads all the SC-Linux related policies and it sets the enforcement of SC-Linux. Okay, and it will set the SC-Linux enforcement as well. So you will learn in detail about SC-Linux in a later tutorial. But for now, just keep in mind that SC-Linux is a set of rules to enhance the security of your system. The third method within main is second stage main. So the second stage main is implemented in init.cpp. Within init.cpp, the main method which we need to look at is property init. So the property init basically initializes the properties within the system. So in Android, there are a lot of properties which are initiated at the startup. So it is very similar to the Windows registry property value pair. I'll show you how we can see the properties. Let me open up the emulator. So to see the properties which are initialized in the emulator, we need to go to the shell and get prop. So this lists all the properties which are set within the system. Okay, these properties are used in many places. So for example, arrow.build.product. So this is the product name of this. You can see this in the settings. If you go to settings, you can see many of these properties listed here. Like for example, if you go to about emulator device, so here you can see the build number, right? So the build number is built from these build properties. Okay, so it's basically a concatenation of all these. Similarly, all these properties are used in many places within the OS while booting up, and also after booting up. It's used for many purposes. Even you can have a runtime resource overlay based on these properties. Okay, so the property init basically loads all the properties, and then we have the init Zygote.rc file. So the init process basically reads this RC file and it starts the Zygote process. Okay, so init.rc is a configuration file with scripts written in an Android init language. So it mainly consists of 5 types of statements, like some action statements, commands, services, options, and imports. So it's a very simple language. So you can Google it to find more information about this init language. Okay, so this init.rc file is actually parsed by the parser.cpp within the init folder, and it will start the Zygote process. So if you want to debug something in this init process, then you can always have a look at the logcat for this tag. So init. So all the activities done in the init will be tagged with this init tag. So you can search for this and find different tasks performed during the init process. Okay, so I hope you have got a high level overview of what's happening in the init process. Thank you.